Morning. My name is Mark Danaher, and I am the BIM manager for Kirby Group. BIM, as we know, is relatively new, but we were kind of thrust into the middle of it with the contracts that we had, where BIM became very important for certain clients, especially the American clients. And what I'm going to look at is more of how we went from a model that would be given to us by the likes of CISC or a company who develops their own model, and how we build into that model. And something that people, I think, forget about BIM is it's great having a model, it's great having all the data inside in it, but you still have to build the job. And a big problem that I see with companies trying to build a job is resistance from people on site. So what I'm going to go through is my workflow. Now, the workflow we've developed is we have tolerances that are given to us by companies that we have to adhere to. And in one such company, we have to install to a tolerance of 25 mil. Now, you try and tell a guy who's been putting conduit in for 20, 30 years that here's your drawing, that has to go into 25 mil, you'll get the conduit hit off your head. Or you'll get told very quickly, where to go. So it's kind of a change in the system of installing mechanical and electrical equipment to a high tolerance. So just what we do as a group, we originally known for our electrical and instrumentation, but we have a very strong mechanical division now, and we're branching out into Europe and possibly Africa, and with mechanical and electrical, we provide a good service where we can do both. We can coordinate between ourselves. We're also doing power stations, a lot of the power stations in the UK. So we're doing transmission and distribution of power. Data centers now, as you know, with all the internet and with backup on servers, there's huge data centers being built in Ireland and throughout Europe, and we've gotten involved in that as well. And we're also involved in calibration, instrumentation and controls. So just some of the clients that we've worked for. I think one thing about Kirby Group is we have a good relationship with our clients, and most of these clients we get repeat business. So we've been with some of these guys for 20, 30 years, and we're constantly moving with them, working with them with innovation. So just key steps of our process. I won't go down through each of them here because I'll be talking about them further on. But it's very important to have a process of installation which goes from your initial design, your initial concept, to actually having it installed on site. And part of that, people talk about BIM and they say, I get this a lot, check the BIM to see is the model okay. BIM is 7D, it's a process, it's a workflow. So at the moment, you heard the lads speaking about 4D and 5D. Kirby Group are at the 5D level of BIM. And for us at the moment, that's exactly where we need to be. So what we do is, what we want is a model that gives us all our different areas, or water, heating, ductwork, ventilation, electrical, mechanical containment. And we want to pull all that together into one model. But not only that, then we go from a 3D model back to 2D drawings. And it's very important that the guys on site get good quality drawings. And it's how do you get from a 3D model to drawings that people can read, understand, and install to a pretty high tolerance. Also, we've taken into account our bill of materials or sequencing of work. That has all been incorporated into our workflow. So I suppose the first area of our workflow would be the package would be released by the design team, the A&E or the GC, would give us a package for us to review. This would normally be a 3D model and 2D drawings, wiring diagrams or whatever. And the design package, what we need to do at this stage is we need to sit down from a 3D perspective and look at this model and interact with the model owners and say, well, no, at this early stage, that can't work. We can't put that like that. This needs to be changed. So the collaboration starts right from the beginning. It's early engagement from our part with the model owners. So after we've agreed that we're happy, we have an internal kickoff. And this is where myself, the system owner, and the construction team, and I think this is very important, that the construction team basically are brought into the design stage at as early as possible. And I always say this, the BIM detailers aren't construction guys. Our guys are straight from college, they're very good at software, but they've never installed trunking, they've never installed ducting, they've never installed a cable tray, wired anything. So what we need is a construction guy who basically builds the model, and he uses our guys as tools to build that model. So my role is to oversee the technical BIM side of it, 3D, the 2D drawings, but where the actual building comes from is our construction team. So the kickoff meeting with our construction guys is very important. Some of the work that we do is retrofits, and what you'll find is 3D models, maybe they may come from a point cloud, a 3D scanner, or they may have been developed just from site surveys. But what we always do is, for whatever area we're working in, we completely survey the site. And we use total stations to scan certain areas that we feel may be problematic in the future. So again, as early as we can, we're getting at the design stage, we're still thinking about construction the whole time. So we haven't done any 3D modelling yet, and we're still in the collaboration phase. So now we're meeting other contractors, we're seeing how they feel about the model, what their ideas are, potential routings where they want to go. Another important thing, I think one of the other speakers mentioned it, was everybody in the one environment. If you're all in the one room, you can, rather than sending emails, calling someone, you can get up, you can walk over, you can ask the question. And we do a lot of work with other contractors. We might be doing electrical, they might be doing mechanical, or vice versa. And it's very important that our BIM detailers are next to those guys. We're all in, even though we're different trades and we might be in competition, ultimately we're on one project and we need to work together. And I think if our BIM detailers see themselves as friends, colleagues of the other trade, things are going to work a lot more smoothly. So this is just Allergan in Mayo, where we did a 3D model and we installed as per the model. Just a few pictures there of it. So our approach to constructability, again, at this stage, we've gotten to a point now where we're happy where we want to go, we're happy working with the other trades. Now we need to finalise ourselves how we're going to construct it. Again, this is where the construction personnel, the site supervisors, the site managers are involved. They're sitting with the BIM detailers, they're sitting with me, and we're deciding what needs to work, what needs to be designed first, what needs to go in first, and how we can actually build it on site. Then our 3D modelling starts, and we use Navisworks for our clash detection and for our coordination with other trades. I think Navis is a great tool. It pulls in most other packages and it builds a good quality model. We also use FADCAB, MEP and Rivet. Rivet I would prefer to use, but it's on the way. It's not widespread just yet. I think it needs to get more mainstream, to be honest. A lot of architects are using it, but mechanical and electrical seem to stay away from it. So another point here is, as the BIM detailers are modelling, they're constantly clash detecting and they're constantly looking at Navisworks and their CAD. And I think that's very important. You need to actually build this stage by stage, and at the end not turn around and say, let's clash detect a full building and have 20,000 clashes, now let's go back and fix it. If it's done at this point, then you save time and you save money. So I think Another good point is the constructability review at 90%. So what we do here is, when we're 90% complete, we have a full meeting, and it's all about constructability. And we look at any potential risks to the construction on site. So here we would have myself and the construction team would sit down, we'd go through the model fully, and we'd highlight potential risks on site again. So we'd go back down with our total station, and again, anywhere where there's a tight fit or there's existing conditions we feel might be out, we scan that area, or we shoot the coordinates with a total station. Now, we've devised a system by where we put spheres into the Navisworks model. Now, the spheres are the points, northing, easting, and elevation that you would get from a point that you shoot. And the sphere size is your tolerance. So if it's 25 mil, your sphere is 25 mil. So in Navis, you will see where we've scanned on the Navis model is a sphere. It might be a blue sphere. And then the actual coordinate from site might be a yellow sphere. And if they don't touch, they're not within tolerance. So we call these our second design review and our third design review before they go to site. And at this point, we're ready to sign off from a design perspective and get site moving. So when we're installing the drawings, for me at the beginning, how do we get the drawings to a level where a guy on site can look at something and install it? You have 20 mil conduit that needs to be installed in a massive building or subfab, and it has to be within its tolerance. So what we've done is, bear in mind now, we've verified all the areas. We use the grid lines, and then we give drawings of plan, elevation, end view, and an isometric. So this would be the installation part. We also then have fabrication drawings, and the fabrication drawings just showing there's hangers there, how they're actually put together. And this then would be our costing. So there can be referred to as BOMs and ISOs, bill of materials and isometrics. So each line of containment is broken out, and next to it then are the cut lengths. And this, again, for costing, is extremely important. So once the drawings have been approved, they can go to site. The approval process, we've come up with a document whereby we've noticed that when you're under pressure, producing the 2D drawing straight from the model is quick. However, you have to dimension, and you have to, there's user error. And to get past this user error, we've come up with a document where each drawing is checked and it's signed off by 3 people. So we have a BIM QA/QC, we have a lead detailer who will sign off, check the drawings, and then before anything goes to site, it gets my final signature. I've checked over them. There's 3 people that have checked them. The drawings need to be good then. So another thing that we've worked on is, as we're installing the drawings are on the way to site, and we've given grid references from pillars, from different walls, grid lines, but they mightn't necessarily be accurate enough for the guys to measure from. So again, we use our total station where we go down and we set out reference points. And we could have 20, 30 reference points. We stick a sticker on whether it's the floor or the pillar, so that the lads know this is where the conduit is measured from, this is where the conduit is sitting, this is where the mechanical duct is sitting. It's all there, it's referenced, it's labelled for them. Again, helping site achieve our goal of getting this containment in and getting it in right the first time. I suppose you can build the model 20 or 30 times, but we all know that labour costs on site, for us anyway, are the biggest expenditure. We need to reduce that, and rework costs an awful lot of money. So if you can build it in a model 20, 30 times a day and then install it in one day, you've saved yourself an awful lot of money. So this again is another project we worked on. It's a plant room that we coordinated within a 3D model. So just our quality manager is here, so we have to throw in our quality. We're the first M&E company to achieve the Q mark. So I suppose advantages of using BIM. Again, I go back to the fact that BIM is a workflow. It's not just a tool. It's many tools, it's many people all working together. So the first thing that will strike anybody who isn't too informed on BIM is that visualization is very important. To have a 3D model there, to have it where guys are installing, they have a screen here, they have their 3D model, they have their drawings, they can visualize exactly what has to happen. That's a big thing. Also, I suppose when you talk about collaboration, a lot of things fall out of that. Time saving. And for us, saving time is money. And you will save an awful lot of money if you can collaborate with guys at the design stage, at a very early stage, before you go to construction. Also, everyone then agrees together on the model. The model is signed off. Everybody knows what they're doing. There's no site arguments. There's no fighting over position. And I suppose it is a strong communication tool, whereby people of different disciplines can be brought together and information can be passed out, sequencing can be done, costing can be done, all through the BIM process. That's it. Thank you.